All right, this is the beginning of homework 4. Apologies on the delay in getting it started. As far as recording, I intended on having this recorded. Having this recorded, a couple days ago, but there were some situations. Plus, I'm recently exiting quarantine, so if you've had to experience that, not that it is, thankfully, thankfully it wasn't bad, but it took a while. So let's go ahead and get to work. All right, problem number 1. Get the stuff up here. Okay, so problem number 1, using the following right triangle, go ahead and, here we go. Go ahead and find the length of side x. Okay, so the easiest way to do this is going to be the quadratic formula. So x squared plus 8 squared is equal to 14 squared. All right, so that's x squared plus 64 is equal to 196. Subtract 64 from both sides, and you get x squared is equal to 132. Square root of both sides, x is equal to the square root of 132, which is approximately equal to square root of the answer. We get a number 11.49 if we round to the nearest hundred. For wherever it's to be sure to round to that, and this is not. There we go. Convert 7 pi over 6 to a radian degree. 7 pi over 6 radians to degree measure. So 7 pi over 6 times radians to degrees is 180 degrees over pi is equal to 7 times 180, which is 1260 pi or 6 pi. Those cancel. We just left with 60, 21 degrees. Wait a minute. 210 degrees. Got my numbers off because that's not divided by 6, divided by 6. That's a 0. 210 degrees. Convert 17 degrees to a radian measure, round to the nearest 100th. This is the scale fact. This is what you change. Okay, so let's do it here. So we have 17 degrees times pi over 180. The degree thing cancels out, and you end up with 17 pi over 180, which is about equal to 17 pi over 180. Give me a number. 0.30 radians. You don't put anything for radians. For degrees, you notice that I make it a point to put the degree signs. For radians, it's nothing. Also, make sure your calculator is in the right thing. Sketch. Theta is equal to 7 pi over 4 in standard position. So this is the unit circle. If you take the time to learn it, you know that pi over 4s split the kind of are in the middle of each of the arcs, each of the quadrant arcs. This is 1 pi over 4, 2 pi over 4, 3, 4, 5, 6, 7 pi over 4 is right here. Boom. That's 7 pi over 4. That's at this location right here. Pretty. That's not bad. All right, find an angle between 0 and 360 that is coterminal with 675 degrees. So what we do is we take 675, we subtract 360. And we subtract 360 enough time until I get between 0 and 360. And I end up with 315 degrees. So that's it for that one. Find an angle between 0 and 2 pi, which is the same concept, with coterminal of 11 pi over 6. So I'm going to take negative 11 pi over 6. And I'm going to add 12 pi over 6 because 2 pi is equal to 12 pi over 6. So I'm going to add a full rotation until I get between 0 and 2 pi. Well, thankfully, I only have to add 1. 12 pi over 6. Negative 11 pi plus 12 pi over 6. And I just end up with positive 1 pi over 6. And that is between 0 and 2 pi. Something that I kind of slid by that I don't want you to slide by is, it says give exact answers for your answers, or exact values for your answers. That means don't round. There's no rounding. You should have an exact number. Keep that in mind. Number 6. A circle has a radius of 6 feet. Find the length S of the arc intersected by the central angle of 1.1 radians. Don't round any immediate computations and round your answer to the nearest tenth. That's important. Don't round any intermediate computations. That's pretty standard. So arc length S is equal to R times theta. R times theta. If I recall correctly, theta has to be in radians. I'm pretty sure. Okay, I'm not sure, but we're going to do it in radians and we're going to see how it works out. Okay, so we plug in our values that we need. R is 6. Theta is 1.1. This is equal to 6.6 feet. Yeah, that's it. And I'm pretty sure I was correct. When you do this formula, S is equal to R times theta, or any of the formulas around it. Make sure you're in radians. Don't do that in degrees. But let us continue. The triangle has side length 8, 15, 17 is shown below. Use these lengths to find the tan of A, sine of A, cosine of A. So this is our angle A. So what we're going to do, we're going to change colors, and we are going to label everything in relation to angle A. So 8 is on the opposite side. It's kind of light. 15 is on the adjacent side. And 17 is the hypotenuse. So that makes all of our values a little easier to calculate. So tangent of A, that is opposite over adjacent. Opposite is 8. Adjacent is 15. That's your answer. Sine of A is equal to opposite over hypotenuse. It is equal to opposite. Opposite is 8. Hypotenuse is 17. So 8 over 17. And cosine of A is equal to adjacent over hypotenuse. Adjacent is 15. Hypotenuse is 17. Uh-oh. Okay. Note that the first thing we do is identify our angle. We identify our opposite side, which does not include the opposite side does not create the angle. The angle is created by the adjacent side and the hypotenuse. If we take B, the angle is created by the adjacent side and the hypotenuse. C is the right angle, so we're going to really use that. Okay, let's go. All right, so we are going to cheat a little bit. So we see in this triangle, we're trying to find theta. We want to find the cosine of theta. Cosine of theta. We have the opposite and we have the hypotenuse. We need the adjacent. But if we look at the triangle right above it, we see that 8, 15, 17 is a Pythagorean triple. In other words, these are whole numbers that make up side lengths for a right triangle. Here we have a right triangle with 17 and 15. This side has to be 8. So cosine of theta is 8 over 17. That's pretty, like I said, we're cheating a little bit, but that one's pretty straightforward. If you didn't have that, then it would be, 17 squared. Well, a squared plus 15 squared is equal to 17 squared. And then solving the Pythagorean theorem for that. Okay, and there's some other ways that you can do it, but this will be the pretty much the easiest, most straightforward way. All right, let's continue. Give tangent theta, secant theta, and sine theta, where theta is shown in the with the angle shown in the figure. Give exact values, not decimal approximations. That means that we're doing sine and cosine and all that stuff. We want to make sure that we keep everything right. Okay, so if we label this side x, then we know that x squared plus 8 squared is equal to 9 squared. I should write that right. So x squared plus 64 is equal to 81. Subtract 64 from both sides. X squared is equal to, I know I shouldn't, but I will, 17. So x is equal to root 17. And we're dealing with this angle here. So now we go ahead and find our values. Tangent of theta is equal to opposite over adjacent, which is equal to, if this is the angle, this is opposite, this is hypotenuse, this is adjacent. Now, do you need to write this every time? No, you do not. But if you need to write it, write it. If you need to write it, the A, the O, and the H to identify your sides, write it. It's okay. All right. So tangent of theta is opposite over adjacent, which is 8 over root 17. And we'll just leave it as that for now. All right. Normally you can't have a radical in the denominator, but it's okay sometimes as you're learning it. Okay. Secant theta. Theta is equal to hypotenuse over adjacent, which is 9 over root 17. And sine of theta is equal to opposite over hypotenuse, which is equal to 8 over 9. That's your answer. Okay. Number 10. A kite is flying 91 feet off the ground, which is identified there. And the string is pulled taut. The angle of elevation of the kite is 62 degrees. Boom. Find the length of the string, write your answer to the nearest 10th. So we have the angle 62 here. We have the opposite side, trying to find the hypotenuse. That means sine. We're using sine for that. Because sine is opposite over hypotenuse. So sine of 62 degrees is equal to 91 over hypotenuse. Okay, we want to solve for h, but we need h in the numerator. So we're going to multiply both sides by h. You end up with h sine of 62 degrees is equal to, those h's cancel, and you just end up with 91. Then we're going to divide by sine of 62 degrees. Because when we put it in our calculator, we want to have to put one thing in one time to solve for what we need as much as possible. We don't want to have to keep going back and forth, because the more you do, the more you get confused. Okay. So that means that h is equal to 91 over sine of 62 degrees is equal to 91 over sine of 62 let's see, load, we are in degrees, put enter, and I get round to the nearest tenth, 103.1 feet. The actual number is 103.063, blah, 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 but it says round to the nearest tenth. Okay, let's continue. Suppose the figure below is a right triangle with side lengths x, y, and z. That's easy. Suppose that the measure of angle x does not equal the measure of angle y. Okay, so not a 45, 45, 90. Okay, complete the following. Part 1. In triangle XYZ, x and y are supplementary, complementary, or neither supplementary or complementary. Okay, supplementary means they add to 180 degrees. It's not that, because the whole triangle equals to 180 degrees. Okay. Complementary means that they add to 90 degrees. So if you look at a triangle, triangles, all the angles, so angle x plus angle y plus angle z is equal to 180 degrees, right? But we know that angle y is 90 degrees. Okay, so we get rid of him and subtract 90 from this one. Then we get angle x plus angle z is equal to 90 degrees. That means that they are complementary. Okay, whenever you have a right triangle, if you exclude the right angle, the other two angles are always complementary. Okay, it is possible for them to equal each other in one case, but they're always complementary. Let's go. All right, so sine of x is equal to the opposite, which is little x, over the adjacent, which is z. Cosine of y is equal to the side adjacent to y, angle y, which is x, over the hypotenuse, which is z. Okay. Similarly, sine of y is opposite over hypotenuse, which is x over z, mean y over z. Cosine of x, you could probably guess what that's going to be. That is adjacent, which is y, over hypotenuse, which is z. And that's our answers. Oh, part 3, select all the true statements. Sine x is equal to cosine y. Sine x is equal to cosine y. True. Cosine x is equal to cosine y. Cosine x, cosine y. Those aren't the same thing. Sine x is equal to sine y? No. Cosine x is equal to sine y. Sine x, sine y. Yes. None of the above. No. So the cosine of 48 degrees is equal to And remember, well, the reason of this problem that they were trying to show, which is these two angles are complementary. Okay, so that means that as we see here, the sine of y is the cosine of x. The sine of x is the cosine of y. So in other words, the cosine of x is equal to sine of whatever. If this is x, this is y. And x plus y is equal to 90 degrees. Okay, so 48. So 90 minus 48 is 42. So this is 42 degrees. Okay, this is powerful. You'll need all this. Let's keep going because I think it's obvious. Kind of sleepy. A ramp 29 feet long, that's this right here, rises to a platform. The bottom of the platform is 16 feet from the foot of the ramp. Boom, boom. Find x, the angle of elevation of the ramp, round to the nearest tenth of a degree. So here, if we consider our triangle here, and our angle x, 16 is the adjacent side, 29 is the hypotenuse. So we have adjacent, hypotenuse, that's cosine. The cosine of x is equal to 16 over 29. So we're trying to find the angle measure, and in that instance, we use our inverse trigonometric functions. Okay, so it's kind of like, I'm going to say it in an algebra kind of way, but it's really not algebra. So what I'm going to do is I'm going to take the arc cosine of both sides. Arc cosine and cosine inverse are the same thing. I like saying arc cosine, arc sine, arc tangent because it completely differentiates it from the previous function. You don't have to worry about thinking that it is the multiplicative inverse and not the inverse of the function. Okay, so cosine and arc cosine cancel each other out. So we have our angle is equal to the arc cosine, -1. That's -1 of 16 over 29. Put that in the calculator, and it does have that 16 over 29. It gives me my angle measure, which is 56.5 degrees. All right, important. 13. Solve the right triangle. Write your answers to the nearest degree. Well, I haven't taught you. There's a few things I haven't taught you yet. So let's do the easy one. So we will say we have, let's label these things. This will be big C. This will be big B. This is little a, little c, that'll be little b. So what we know is that a plus b is equal to 90 degrees. All right, b is 42 degrees. So that means that a plus 42 degrees is equal to 90 degrees. We already know a is equal to 48 degrees. All right, so now we have all of our angle measures. We can make it easy. The easiest way to do it is if we have our variable in the numerator. Okay, so from 48, I can do, sine, cosine, tangent, or whatever to do it, but I'm going to do tangent. You'll see it, I'm on it. Tangent of 48 degrees is equal to a over 24. Looks like a 9. All right, if I multiply both sides by 24, then I get 24 tangent of 48 is equal to a. So you see, I don't have to divide by anything. I don't like to do that if I don't have to. 24 tangent of 48, and I get 26.7, which is A. $26.7. Let's say it doesn't say what it is. So I have that. So now I need to find C. It's going to have to be in the denominator because it's the hypotenuse. So we'll just say but I like to use, because I rounded to get what A was, I want to use what little b is because this is what's given. I want to use the given information if at all possible. It didn't really matter that much because 42, 48, there are no decimals, there's no rounding, there's no anything. Okay, so for A, we'll say that is cosine of A, cosine of 48 degrees is equal to 24 over C. Let me put a circle around that one. Put a circle around that one. Okay, so that means that multiply both sides by C. C cosine of 48 degrees is equal to 24. Divide by cosine of 48. All right, and you end up with C being equal to 24 over cosine of 48 degrees, which is equal to 24 over cosine of 48, 35.9. And those are my answers. Get that A in there. Boom. Those are my answers. I had to solve for 1, 2, 3 things. One of them was really easy, so I really only solved for 2. All right. Looking up, Rana sees 2 hot air balloons in the sky as shown. She determined that the lower hot air balloon is 670 meters away at an angle 42 degrees from the vertical. The higher hot air balloon is 945 meters away at an angle of 36 from the vertical. How much higher is the balloon on the right than the balloon on the left? So what we're trying to find is this side. I can label it. Maybe not in red. What I'm trying to find is this side. And then I'm really trying to find this little piece right here. Okay, I'm trying to find this little piece right here. I need to find the big length, the little length, and then subtract them. Okay, so we'll do the little length first. We can do either one first, really. So the little length first, we are trying to find this side. We'll call it, I don't know, B. And we have this angle 42. So we have the adjacent, to this angle, we have the adjacent side, the hypotenuse. That's cosine. So cosine of 42 degrees is equal to, I don't know, I don't know, we'll say that this is X. X over 670. But it's little part X. We'll call the big line Y. All right, so 670 cosine of 42 degrees is equal to X. And that is 670 cosine of 42 is equal to, it says don't round it immediately. So we'll say 497.907, blah, blah, blah. All right, I say blah, blah, blah here. What we're going to do is, I wrote that so I remember what it is. X is equal to. But when I actually do the subtraction, I'm going to go back in my calculator to that and subtract that value. Okay, keep that in mind. For the big one, we have Y. That's the adjacent hypotenuse. We're doing cosine again. So cosine of 36 degrees is equal to Y over 945. So 945 cosine of 36 degrees is equal to y. So y is about equal to 945 cosine of 36 degrees, 764.52 some other. But it's here in my calculator. So from here, I push minus, then I go back up to the line that I was using, push enter, and then I push enter again. And I have what I need to have round to the nearest tenth. Y minus x, that's going to equal 266.6 meters. Boom. So that is the conclusion of our homework practice questions for homework 4. If you have any questions about it, please feel free to let me know.